Hello good people, welcome once more to Slap Tutorials C Programming to be precise. Alright, so I'm not even going to waste time. I have my skeleton. I hope you have your skeleton. And in this tutorial video we're going to talk about arithmetic operations. Yes, you know them. They're addition, subtraction, multiplication and division. Those are the basic arithmetic operations. And I'm going to show you how to implement these arithmetic operations, and I'm probably just going to leave in a little bit of juicy stuff so you know about other arithmetic operations. So let's save up our file as arithmetics. Let's see. Alright, so we have that in place. So the first thing I'm going to do, I'm going to show you how to add two integers, okay, and let these integers be already giving variables with values. Okay, so let's say int a equals to 5 comma b equal to 10. all right, now we should expect the result a plus b to be 15. okay, so let's have another variable called sum. Okay, so we have three variables, one called a which has a value 5, another b which has value 10, another one sum which doesn't have a value, but we're going to assign a value to it. And what value do you think we're going to assign to sum? Obviously the result of a plus b. That's the sum of a and b. So we're going to just do sum equals to a plus b, and I'm just going to simply print out the sum. Alright, so we have, now I could do this, percentage d plus percentage d equals percentage d, saying the first percentage d, it is a, second is b, and the third is the sum. Alright, so I save that up, compile, and I run. Alright, 5 plus 10 equals 15. Oops, my bad, no break. Alright, so that is what we expect. 5 plus 10 equals 15. So you can actually add numbers in C programming. You can as well subtract. So just don't be worried. Let me just put some comments over here. I'm pretty sure you know how to put comments. This is how you can comment a whole block of code. Alright, with this forward slash hash star, I don't know, star and forward slash. Okay, so to add, you have this. So I'm gonna just subtract. You have that. It's just the hyphen. To multiply, you have that, and to divide, you have a forward slash. Alright, so keep that in mind. Now if you want to add a single line comment, you do it with that. So if you go to the next line, it doesn't longer become a comment. You can see it's not green anymore. Alright, so we have just added two integers, given the fact that the integers had values from their initialization. Alright, so what if these integers don't have values, meaning that we want to tell the user, okay, give me a value and I'm going to add those two values? It's really simple to do. So we're just going to, let's leave that above. We're just going to ask for other integers. So let's just do int. Okay, int number 1 comma number 2. Right, let's do that, and then let's say, what do you want to do? Let's see subtraction. Okay, subtract. Alright, let's do that. And so we'll ask the user printf. Okay, I'm going to show you something really cool here. Some of you might not get it now, but they're really cool tips and shortcuts. Okay, so I'll tell the user enter two integers \n. So if I do a scanf, I can actually do a scanf for all the number of variables which there exist. So I want to do variables for two, number 1 and number 2. Okay, so I'll do percentage d comma, and ampersand number 1, comma, ampersand num2. Alright, so in the end I could do subtract equals to num. Alright, so practically, okay, for now probably we shouldn't use subtract, let's still do sum. My bad. If we do sum here, we're going to be overwriting this because this is already sum and it has a value and you're redeclaring sum. So let's just do sum. I really think you understand because the sum above are all in lowercase letters, meanwhile the sum below are in lowercase letters with the first letter just being uppercase. So those are really two different variables. Alright, so note that to name a variable, variables are case sensitive. So if you use lowercasing throughout has to be lowercasing when you want to identify the variable. So we have num1 plus num2. Let's print out a sum. Alright, so let's just write sum egat equals sum. My bad. Compile, no errors, run. So you have entered two integers. So let's just say our first integer is 90 and our second one is 8. So sum equals 98. Press any key to continue. I always forget the \n. It's just for presentation and I really like presentation, so I seriously have to do this again. Voila! It looks perfect. It looks much more better than before. So we know how to add up, so we're going to do subtraction, we're going to do multiplication, we're going to do division. So with these same numbers, let's probably add another variable here called product, and we'll come here to the computer product equal to num times num2. Okay, it's num1 multiplied by num2. Alright, so I'm just going to copy this print statement. Bad habits for people who don't know, so I suggest you do not do that if you're not versed with it. I always get my spellings wrong. Please, I have you know it's just a temporary error. So here is product. Alright, okay, you can save that, compile, run. So I'm not going to take 90 and 98 anymore. I'm just going to go 5. I'm going to go 10. So I know that 10 times 5 is actually 50 and 10 plus 5 is 15. So you see that the star actually works. So that is how to multiply. Now let's try to divide. I am keeping. Okay, now let's try to subtract. Alright, let's try to subtract. I want to show you the beauty of this subtraction. I don't know why I wrote subtract. So let's do diff as in difference. Okie dokie. Save, build, run. So let's say my first integer is 10 and my second is 5. We expect from here that the sum should give us 15, the product should give us 50, and the difference should give us 5. It's actually going to give us 5. But what if I replace the positioning of my integers and I said 5 and 10? We expect the same results, but just for the difference we need -5. And it's actually cool how a compiler understands that, hey, the first number is smaller than the second number, so it has to do reverse addition. Alright, so it's supposed to remove 5 from 10 and just give it a negative sign. Just that simple, so that you don't need to bother about if the first number is smaller than the second number. The compiler knows. It's pretty smart. That is what it was made to do. So the last thing we're going to do with the arithmetics is the division, so that's ratio. So now ratio is num1 divided by num2, and come here ratio. I'm pretty sure by now you should have had a hang of it. Okay, so keep practicing and everything is really going to go fine. Ratio. So again I'm going to do my 10 and I'm going to do my 5, because I know that 10 divided by 5 is 2. Now everything works good for the good of those who believe, and if you believe that your compiler can do it, it's probably going to do it. But in this case, the compiler is going to mess you up if you say 5 and 10. Now 5 divided by 10 is not 0, it is 0.5. We all know that it's 0.5. But why does our compiler give us 0? That is really absurd. So I'm not going to tell you now. You're going to have to wait till the next tutorial to come and actually know why and how to fix it. Okay, I'm just kidding. I'm really going to tell you now, because I cannot keep the secret to myself. I must teach you. You need to know. You need to pass the GCE. So what the reason is because we're dealing with integers, and integers are whole numbers. Okay, positive or negative whole numbers. That is why when you do 5 minus 10, it actually gives you negative 5. All right. If you had to do, if probably we could identify, we could decide that we want to give not integers, natural numbers, just positive whole numbers. If you do 5 minus 10, it's probably not going to give you negative 5. It's not going to do that. Alright, so in this case, integers cannot display with decimals. They're not fractions, they're positive or negative whole numbers. So we need to bring a situation where we either declare a real number for ratio, or we declare a floating point number, which are actually decimal variable, decimal number. So for ratio, I'm just going to end this here, break that line, and I do float. Okay, float ratio, meaning it's a floating point number which are actually decimal numbers, and instead of percentage d, I'll do percentage f. And if I compile and I run and I use the same values 5 and 10, it's going to probably give me something really long decimal number, 0.00000. And why is it giving that? Because we've made notion of the fact that 5 and 10 are still integers. All right, 5 and 10 are still integers. So what we need to do, we need to take num1 and num2, zubidubi zubidubi bam bam, zubidubi param bam, num1 and num2 to also be floating point numbers. All right, so we're just going to go through a couple of things with the scan f. Change this to percentage f, percentage f, try to run that, and 5 and 10, and we have 0.5 0. So by default, if we count, we have 5 0 0 0 0 0. We have 6 DPs, all right, 6 decimal places. So by default, the format specifier for floating point numbers in the C program come with 6 decimal points. We can change that. We can actually make it 4 decimal points or 3 or 2. So for this exercise, let's do it 2 decimal points. So we want to come down here where it's being printed out, right here, right here, and we do percentage dot 2f. okay, meaning we want it to reduce itself down to 2 decimal points. So if I do 5 and if I do 10, it's going to give me in 2 decimal places. So if you want 10 decimal places, you're probably going to write dot 10. I don't know, I've never tried it. Now that I say it, I really want to try it. 5 10. Oh shucks, it gives you in 10 decimal places. All right, so that's how you reduce the number of decimal places and you increase the number of decimal places. So for standards, you might probably want to leave it at 3 dp, because the numbers that we probably have 0.025. okay, that's probably where you draw the line at the 10th decimal place. So for simplicity's sake, we're going to leave it at 3 decimal places. So remember, if you have numbers dividing, you probably want to use a data type like a floating number or double. Okay, you can decide to, instead of floats, we do double. Let me just show you like real quick. So is LF for double, that's the format specifier. Save, build, and I still do 10 and 5 and 10, and it gives me the same 0.500 to 3GP. So you can either do double or float. That's similar. It's like saying all numbers on earth fall under the set of real numbers, positive or negative numbers. So it doesn't matter whether they're positive or negative or they're rational or whatever, all of them are real numbers. I hope I'm saying the right thing, because I am. Alright, so there we have it. You now know how to perform basic arithmetic operations. So that's simply it. And alright, I said I was going to show you something really cool. And here we have just the normal things. So some of you right now are thinking, what if I want to do square root of a number? How am I going to do that? What if I want to raise a number to the power of something? Now, for people who like to think a little bit out of the box, if you want to raise a number to the power of another number, I would just suggest you multiply the number that number of times. Because we know that 2 to the power 3 is 2 times 2 times 2. So instead of using some sort of mathematical expression, just do 2 by 2 by 2. It makes life simple for you at your level. But if you want to know, I can always show you. So for what I want to show you right now is the square root function, okay? The square root function, which is not found in this header. So all good things cannot come from one place. So there is a header, okay, called the math header. So it's just this, math.h, okay? Now keep in mind, if you include headers and you don't use them, nothing is going to actually happen. It's still just going to work perfectly fine. Okay, so you might include 10 headers and only one you actually use instructions from there, nothing is going to happen. But if you include an instruction without its header file being present, obviously you have an error. So for example, if I come here and I do studio, not studio, studio, and I save and I compile, it's going to give me an error. Can't find studio.h. That's a common mistake. People always, at beginners, they always be like, memorize a studio. I did that, guilty as charged. Alright, so for a square root of a number, let's take a famous number here. Probably let's do this here, please. It just looks perfect. So if I want the square root of a number a, I can decide, alright, give me let's create a variable called sq for square root. Alright, I will decide that sq is equal to the square root, okay, that's the square root function of the number. Of what number right now? Of probably, what's the square root of? So let's change this. Let's change this to 9, okay? So we can see the square root of a, that's the square root of 9, which is 3. And so I'm going to print this out. Square root of percentage d is percentage d backslash n. Square root of a is a scale. Okay, you build that and you run it and you have square root of 9 is 3. So what I wanted to show you was how you can use another header to do different things. So if you want to do the square root of a number, that's it. Okay, you need the square root header and you need the square root function. So I'm just showing you the square root function. Trust me, you're not always going to find this, but you're always going to find it if you look for it, but you're not always going to look for it. Why am I doing this? Because some of you now are already thinking, alright, I can probably build a calculator. We are going to build a calculator. I can probably do the, how did I call this, b squared minus 4ac, square root of b squared minus 4ac, the discriminant, quadratic equation. You probably want to write a program to solve that. Yes, I mean, you're probably getting it up right now, you're excited. Hopefully we're going to cover that up. Yeah, we are going to cover that up. And so I'm just showing you a glimpse of this before we reach. So it's just like a sneak peek into all what we're going to be doing. So not to eat up much of your time on this, thank you very much for being patient with us. Thank you for studying with Slap, and see you in the next tutorials. Slap out.